Okay, do not forget the strategies that we learned yesterday. The one that I would go to on this one is that whole sines and cosines. And again, that's going to be your safety net. If you know nothing else, try that. Okay, and see where it leads. So tangent being sine over cosine. Pay attention to our signs between. Sometimes I saw us being a little loose with what those were. If it's addition, keep it addition. If it's multiplication, keep it multiplication. So it is multiplication here. Cosecant is 1 over sine. And cosine I would not change because it's already in terms of sines and cosines. But I can make it look like fraction if I want to. You don't have to understand that it is in the numerator, but if it makes you feel more comfortable by putting it over 1, so they're all fractions, do that. Helps me recognize things that can simplify. A sine in the numerator and the denominator will simplify to 1. A cosine in the numerator and denominator will simplify to 1. And that's all the work we have to show on this one, because multiplying straight across the top, straight across the bottom is 1, and that matches the other side. Okay, yesterday we got introduced to a couple of techniques, sines and cosines, looking for Pythagorean identities. Don't forget those, okay? We are adding to our list of strategies, our toolbox that we can go to say, how can I simplify this problem? So I'm not saying that these problems can't be done by what we did yesterday, but we're going to see some other techniques show up here. So one of the things you can look at is factoring. Factoring out a GCF being one of our techniques for factoring. When would I look at factoring out a GCF? You would look at this if you have something that is a binomial or a trinomial, meaning we've got things that are separated by addition or subtraction. And as I look at those, here would be my first term, and my second term would be here. And if those terms have something in common, factoring out a GCF might be a strategy that we look at. So in this one, I can see that the first term has a cosine of x, and the second term also has a cosine of x. Similar to if we saw something like a minus ab, is that we can factor an a out of both of those, okay? So I pull that GCF out front. Remember that when you are factoring out a GCF, you still have to have the same number of terms. So we still have to have 2 terms. That I consider what's left over if I were to like go back and divide by that GCF. So if I came back up here and I said, okay, I'm going to divide by the GCF I just factored out, what would I get? Well, cosine over cosine would be 1, right? Minus, and my cosines here would simplify, leaving me with just sine squared. Questions? So here's the kind of challenge of saying strategies, is because now do you see a strategy that we used yesterday? Your Pythagorean identity showing up, right? What am I able to replace 1 minus sine squared with? Cosine squared, right? That's one of our Pythagorean identities. So now I can continue on, bring my GCF still down here, replace this part with its Pythagorean identity, cosine squared. And again, think algebra. X times x squared is x cubed. So cosine times cosine squared is cosine cubed, which is exactly where we were trying to head in this one. So new strategy today, factoring out a GCF. We have terms split by plus or minus. They have something in common. Not always where we will go with it, but if it helps, we can do that. Okay, questions on factoring out a GCF? Okay, getting a common denominator. And right now, as you look at this particular problem, you might say, okay, common denominator I think of associated with fractions, and I see 0 fractions on this screen, right? So yes, common denominator, and we saw an intro to this yesterday. We don't have any fractions, but if I were to use our strategy from yesterday of flipping to sines and cosines, will I have fractions on my picture now? Yeah, absolutely. So that's where this is going to come. And again, we got an intro to common denominator yesterday on our assignment, on our check for understanding. But just to kind of reiterate that technique, it comes after switching to sines and cosines, and then we have fractions. So if I start this by turning to sines and cosines, tangent is sine of x over cosine of x. And if I simplify this first term, multiplying straight across the top, straight across the bottom, I get sine squared over cosine of x. Now remember your algebra rules. I see a cosine in the denominator and the numerator, and sometimes we're tempted to cross those off like they simplify. What is stopping me from doing that? The addition sign between them, right? We cannot simplify across a plus or a minus, only if it was to be multiplication between them. So now let's get the common denominator part of this. I don't even have a denominator here. It is 1 if we don't have one, right? And in order to add fractions together, which clearly we need to do because we don't have two separate terms over here. So at some point, we're going to need to put this into one term. I need to get a common denominator. My common denominator has to represent all of every denominator. We have a cosine of x over here and a 1. So our common denominator is cosine of x. This fraction over here would have to be multiplied top and bottom by cosine of x to get it to have the common denominator. So our sine squared over cosine is not changing. Over here, multiplying straight across the top, straight across the bottom, I will now have a cosine squared over cosine. Now I have a common denominator in which I can add those two terms together, keeping the common denominator. And we go back to yesterday. Sine squared plus cosine squared can be replaced with or substitute in for what? 1. And 1 over cosine of x is secant x, which is where we were headed, and we are done. Okay, so that is your basic, and we saw an intro to that yesterday, so I think that this kind of makes sense, but we will see this in a couple other ways. So when we're dealing with fractions, if your goal is to put them together, remember the algebra rule that if we are adding fractions together, we have to have a common denominator. So let's see one that's a touch more complex. So as we look at this one, I would clearly work with the right-hand side on this one. And by right hand, I mean left. Left-hand side is the more complex side, right? And we always want to pick the more complex side. It is easier to simplify than it is to make something complex. These fractions have different denominators, and there is no two terms over here. So clearly I want to put them together, right? So in order to add two fractions together, I have to have a common denominator. Your common denominator must represent all of every denominator. So we must have a sine of x from our second fraction. We must have a 1 plus cosine of x from our first fraction. And then what I will give you advice on is don't distribute. Okay, when you are doing this, and you guys are going to see this over and over and over again, it will eventually simplify. Leave them separate. Okay, just show what's going down there. Sometimes people like, well, to simplify things fast. When you are doing these types of problems, don't do too much at one time. Okay, so that's our common denominator. And then to again, adjust your fraction. We say, okay, this first fraction has the 1 plus cosine x. It's missing the sine of x. So it would have had to be multiplied by sine of x, top and bottom. Multiply in the top, sine times sine is sine squared. Same thing over here. We've got the sine of x part. We don't have the 1 plus cosine of x. And here's where you have to, again, be a good algebra student. I have a binomial here that I am multiplying by a binomial. What process do I need to do? FOIL, right? I have two terms times two terms. In order to multiply those together, you have to FOIL. And just slow down and FOIL, okay? Let the process guide you. 1 times 1 is 1. 1, actually, I'm going to write this up one step higher here. 1 times cosine of x is cosine of x. Cosine of x times 1 is cosine of x. And cosine times cosine is cosine squared. I can clean this up just a little bit, that cosine of x plus cosine of x is two of those, right? It'd be like x plus x is 2x. Cosine plus cosine is two cosines. Questions so far? Okay. Now that I have the common denominator, I can add those two fractions together. And again, guys, you're going to see this one show up multiple times in slightly different forms. I can now put all that together, but none of these are like terms, right? So it looks like I'm going to have like four things sitting in my numerator at this point. And I'm going to strategically reorder this one. They'll all be there, but I'm going to write it back. Well, I'm going to put this one first. Plus cosine squared plus 1 plus 2 cosine x. Okay. Now I strategically did that, and I want you to pause here. Does anyone have a guess as to why I strategically reordered those? It's addition, right? I can do that, can't I? Does anyone see anything emerging in our numerator? Like over and over and over. What is sine squared plus cosine squared? 1, right? So I can now sub in for the sine squared plus cosine squared 1. Now, I will tell you right now, I don't typically do this much work or show this many steps. That a couple of these can be put together. Like you can jump from here to the one I'm going to write after here, because what is 1 plus 1? 2, right? All right. Here is where you're going to need to see this and maybe make a note for yourself because you're going to see this same process happen multiple times. Right now, it looks like nothing simplifies in my fraction. Agreed? Nothing quite matches top to bottom. But do you see in the top that both of our terms have a GCF of 2? Right now, it's like 2 plus 2x. Can I factor a 2 out of that? Yes. So I can factor a 2 out of this and call it 2 times, and then I'd have 1 plus 1 cosine of x. Why did I do that? Can I simplify my fraction now? 1 plus cosine of x in my numerator, 1 plus cosine of x in my denominator. Leaves me with 2 over sine of x. And 2 over sine of x is the same thing. And I'm going to do this. I don't normally show this step, but this really is like 2 times 1 over sine of x, right? You guys okay with that? Because 1 over sine of x is cosecant x. I usually just go from this to this, but just so you understand where that's coming from. The sine of x in the bottom is like 1 over sine of x, and 1 over sine of x is cosecant x. Okay, I know that I just showed a crazy amount of work. I will tell you that I don't typically show like this line. Can you? Absolutely. I don't typically show this one right here. Can you? Absolutely. So we can skip a few of these. It doesn't have to be this crazy long, but that's how you get to this one. Questions for me? Okay. Next strategy, conjugate. We have heard that word before. And the conjugate meant the same two terms, but opposite signs. Now, we typically use the conjugate with the denominator of our fraction to get rid of a radical. That's where you probably, if you're remembering this word, that's where you would remember it from, is that I had something with like a 1 plus the square root of 3, and I multiplied by 1 minus the square root of 3 to get rid of it. Okay, or to not have a radical in our denominator anymore. We can use that conjugate idea on these problems, but it doesn't have to necessarily be your denominator. We can work with the left-hand side here. So here's how a conjugate can help us. If your denominator or numerator is 1, and I would say specifically use this with cosines. It really is not typically helpful with anything but sines and cosines, okay? If it's 1 plus or minus cosine, 1 plus or minus sine, I might consider this strategy of conjugate. If it's secant or cosecant, tangent or cotangent, we'll look at another option here in another slide here. But I can work with the left-hand side here and use the conjugate. Now, in order to keep this fraction equal, I have to do that to my numerator and denominator. Now, in the numerator, I would not distribute. Just like I talked about on the last slide here. No, it was the last slide? Yeah, don't distribute because eventually something's going to simplify. That's my whole goal. So I'm not going to distribute. I'm going to just leave it as is. So my numerator is going to sit as just sine of x times 1 minus cosine of x. But the denominator, I do want to multiply that out. Okay. Now you may or may not recognize it at the beginning here, but it is a set up as it going to be a difference of 2 squares. That's why we use conjugates, right? Now, if I forget that, if I FOIL 1 plus cosine of x minus cosine of x minus cosine squared of x, your middle 2 terms will always simplify. Cosine minus cosine is 0, okay? So that numerator becomes 1 minus cosine squared. When we set up a conjugate, when we use those opposite signs in there, we'll always get first thing squared minus second thing squared, right? And now we can use our Pythagorean identity. What can I sub in here for 1 minus cosine squared? Sine squared. Okay. This is why I told you not to distribute. Do you see what I can now simplify? My GCF out here with one of the signs in the denominator. Okay, so I can simplify a sign in the top and bottom, leaving me with 1 minus cosine x over sine x. Which is where we were going. Done. We matched the right-hand side. Conjugate strategy. Questions? Okay, last new strategy for us. Now, when I start this next problem, I put this one up here because it, first of all, looks to me like, wouldn't I just do this like the same as I did on the last page? And I'm going to show you the difference between this. Is right here, not a sine or a cosine. If it is anything else, which this one is cosecant, if this does not say sine or cosine, conjugate method is usually not going to get you anywhere with this. Okay, it's not wrong, it's just not going to be helpful. If it is anything secant, cosecant, tangent, cotangent, what you want to do is get these to both be single fractions. And let me show you how to do that. Okay, so in order for these to be fractions, now this one does not have a, this is sine, so I just leave it as 1 plus sine. If it was anything other than sine, I would do what I'm about to do in the denominator here. So let's look at our denominator. First thing I would do is write this in terms of sines and cosines. So this applies to any time that it is plus or minus, whether it is numerator or denominator. If it is plus or minus anything other than sine and cosine, secant, cosecant, tangent, cotangent, I would go this route right here, and I would get this to be one fraction. So now I'm going to think about getting a common denominator to put those together. So my common denominator is going to be sine of x. So I'd multiply here by sine of x. Okay, well, that's just going to be sine over sine. It's 1, right? So we're looking at my colors right here. And I'm going to try to color coordinate this one so you can follow where everything ends up. Now I can put my denominator together here. To be sine of x plus 1 over that common denominator of sine of x. So I took the denominator, I got a common, I turned it into sines and cosines to get a fraction. I got a common denominator to make it one fraction. The reason I did that is now I can multiply by its reciprocal, right? That's what we do when we have a fraction in our denominator, is I take my numerator, there's my numerator, times the reciprocal of our denominator. Now, sometimes order matters and sometimes it does not. If it is addition, is it okay that they are opposite of which one's first and which one's second? It is. So what we're looking at here is if I think about this being a fraction as well, I've got a sine of x plus 1 and a sine of x plus 1 in my numerator and my denominator. Multiply straight across the top, straight across the bottom with what's left, and that is just sine of x. Okay, so what's the difference between doing the conjugate and this route? Again, it's completely by what term we're looking at. Are we looking at a secant, cosecant, tangent, cotangent? Then I go this route. Turn to sines and cosines, get a common denominator, make it one fraction. So I can multiply by its reciprocal. If we look back at this one, which looked very similar, the difference is it said cosine or sine. Either way, I would do conjugate. Okay. So again, guys, I understand that we are not going to walk out of here today feeling super confident. It comes through practice, through trial, error, through watching these videos again, if that is helpful to you. And so what I would do is, as you sit down with your worksheet, you're going to look at a problem. And if you know how to start it, great. If you don't, you're going to scan through all of your notes and say, is there one that kind of looks like that that might give me an idea of how I could attack this? Okay. Utilize those notes because I'm picking these strategically for what is on the worksheet. I can't cover everything, but I can give you some ideas. Okay. All right. Let's look at one last one again. I know it says check for understanding, but let's kind of talk through this together here. So I've got 1 minus, and then the fraction cosine squared over 1 plus sine x, and we're supposed to say that this equals sine x. What strategy do you think we might employ here? Or kind of an algebraic process? Maybe back my question up here. Would you work with the right-hand side or the left-hand side? Left-hand side, right? So here's what I'm seeing on the left-hand side. I'm seeing a 1. I'm seeing it separated with a subtraction, and then I'm seeing a fraction. Okay, so what I'm seeing is 2 separate terms. Would you guys agree with that? On the right-hand side, do we have 2 separate terms? No, you have sine of x. So what does that tell me? That tells me that I need to get it to go together, right? It's right now 2 separate things, and I need it to equal 1 thing. So to get those together, what do you need? A common denominator. Okay. So take a second and get a common denominator. Our common denominator would be this whole thing, right? So I'd have to multiply by 1 plus sine of x, top and bottom. Pause there. I just got my common denominator. Questions? Okay. Put them together. Now, this one's a little tricky as far as how it is written, but do you see the Pythagorean identity that's emerging in there? Because we can switch the order here, do you see the 1 minus cosine squared? What can I replace or sub in for 1 minus cosine squared? Sine squared. I don't know where to go now. Seem to be a long ways from just a plain old sine of x. Think about some of the things we talked about today. GCF. What has a GCF? Numerator, right? They both have a sine of x. Sine squared, sine, two terms separated by plus GCF. Again, does it matter that my order is wrong here? No, it's addition, right? So now there's our key. So today, keep on your radar getting common denominators. Keep on your radar factoring out things like a GCF, conjugates, right? That's kind of all the things we added to our strategies today as you start working through your worksheet. And again, I will tell you, you should not feel like you've got this all down today. If you do, that's amazing, and you're ahead of the curve. You're going to probably run into one that's at least one that's going to make you hesitate. If not, 10. Okay? And that's okay. It is okay at this point to feel that way. I promise you. As long as you're doing your homework. It's only 10 problems.